Example 6. Notice that these are getting a little bit longer. So here, instructions are the same. Process is pretty much the same. Our goal is to simplify first and then switch this division into multiplication. But our way that we simplify is going to look different than it did in the last two problems. So what we need to do first is do as much factoring as possible, then simplify, then we'll multiply. All right. So first things first, let's work on factoring. Looking at this first fraction, x to the fourth minus 9x squared. The greatest common factor here is x squared. That would leave me with x squared minus 9. The denominator, x squared minus 4x minus 3, is going to factor into x minus 3 and x minus 1. And that is being divided by, if we look at the numerator, x to the fourth plus 2x cubed minus 8x squared, greatest common factor here, oh, and you can't see that part, sorry about that. Greatest common factor here is x squared, which will then leave me with x squared plus 2x minus 8. X squared minus 16 doesn't look like it can be factored, but I want to remind you of our difference of squares factor pattern that I can write on the board for us here. Our difference of squares factor pattern says if I have some number squared minus another number squared, so subtracting two perfect squares, that's going to factor into a plus b times a minus b. Right? So that's our difference of squares factor pattern. So we have a squared minus b squared equals a plus b times a minus b. So x squared and 16 are both perfect squares because 16 could be rewritten as 4 squared. So x squared minus 4 squared is going to factor into x plus 4 times x minus 4. All right. Let's continue our factoring process here, and I'm going to move myself over here. Okay. So now, continuing to factor this first fraction even further, I'm going to have x squared, and then x squared minus 9 is another difference of two perfect squares, because 9 is the same thing as 3 squared. So this will give me x plus 3 times x minus 3. The denominator of this first fraction cannot be simplified any further. I'm going to change my division symbol into a multiplication sign. And I'm going to take this second fraction and flip it around. So x plus 4 and x minus 4 is in the numerator. My denominator, factoring the x squared plus 2x minus 8 further, will give me x plus 4 and x minus 2. So far, we've done a lot of factoring, and we have changed the division sign to multiplication, and we have flipped the second fraction. Now, let's cross out any of these common factors between the numerator and denominator. Well, I have an x minus 3, and I have some x plus 4s. So within the two fractions, crossing out the common factors, and then multiplying what's left straight across, is going to leave me with, and I have to shrink this down. So I wrote a little bit too big, so I apologize, but I have to resize this just a touch. I'm going to be left with x squared, x plus 3, x minus 4 if I multiply all the remaining pieces in my numerator. The denominator, I'll be left with x minus 1, x squared, and x minus 2. Looking at all my new factor pieces, I have one more common factor of x squared that I can cancel out. So my very final answer, yes, we are almost done, is x plus 3 times x minus 4 all over x minus 1 times x minus 2. Now from here you could go through and multiply everything back out to get it into standard form. So taking the x plus 3 times the x minus 4 would give us x squared minus x minus 12. Taking the x minus 1 times the x minus 2 would give us x squared minus 3x plus 2. For the sake of Algebra 1 or Algebra 2 though, at the non-honors level, Mr. Brasser and I will accept either versions of these two answers. This was a very long problem. It was the longest problem we've done all lesson, but know that the difficulty in this problem is the highest level of difficulty you can expect to see with these problems. Okay, so I know that they take a little bit of time, but with practice they will get a lot easier. All right, we have one example left, which is much shorter than this one. Example 7. We want to solve and check your solution. So the goal is to solve for x. It's going to start off the exact same way as the other problems did. So we are first going to factor the numerator because we want to simplify, and it's going to factor into x plus 5 and x minus 2, leaving me with x minus 2 in the denominator still and equals 7. Notice that I have a common factor that I can divide out, the x minus 2's. That's going to leave me with x plus 5 is equal to 7. Solving for x, not too bad. Subtract 5, and I get x is equal to 2. But what if I told you that there really is no solution here? And that's because, well, x can't equal 2, because at the very beginning of the problem, if x equals 2, it gives us 0 on our denominator. Well, that's not good. X can't equal 2 because we are not allowed to divide by 0. So, even though we did all the algebra right and we got an answer of x equals 2, there really is no solution. So x can't equal 2 because of the denominator. So we say that there is no solution. All right, now this is the very end of 5.2, multiplying and dividing rational expressions.